Hello everyone, this is Arman with Metaspec. Thank you for joining me here. I'm very excited today to be launching our new software, Forensic Email Intelligence. Before we start, I would like to give you a little bit of background on what the backstory is and why we decided to create the software in the first place. So some of you already know that I'm deeply involved in email forensics, so it's kind of a focal point in my career, at least for the time being. And the initial challenge we had around email forensics was to secure the email evidence. So essentially connect to any type of email server, gather the evidence, connect in a read-only manner without disturbing anything, get the email evidence we need and the format we need, along with the surrounding evidence like server metadata, logs, history records from Gmail, later on cloud attachments and all that. And we largely accomplished that with Forensic Email Collector, which was our first tool. And now that we have that in place, the next step in the workflow for me typically is to analyze the emails. And what I've been doing for a while now is to use a collection of different homemade tools and scripts to get that done, because in terms of email analysis, the tools that were available to me have been fairly limited. And when I say email analysis, what I mean is if you follow our blog, for example, or our digital forensics community, you'll see some research around identifying email clients based on markers like message IDs, code strings, decoding hidden timestamps and email headers, email message IDs, service IDs, thread identifiers, and things like that. So a lot of deep dive information about email headers, MAPI properties, and then intelligence stuff that involves enrichment of data to get more information about the email, IP addresses, domain names, email addresses, URLs, and things like that. So, there are a lot of tools that we use as full forensic suites, and they do a great job of ingesting emails, searching emails, and showing you the basic information about email metadata, headers, and things like that. But we were having a hard time getting email signatures verified and getting the intelligence that we need from emails. So we built this tool to kind of take it from there, where Forensic Email Collector left off, and do a deep dive on individual emails and then scale that to large amounts of emails and show you the kind of information you would need in any actual email investigation. Now, without further ado, let me share my screen and I'll walk you through the software and a few use cases, and there are a few different ways of using it too, so I'll walk you through those. And there's whatever platform you're watching on, there's going to be some chat options, so if you have any questions, feel free to drop them there, and I'll check towards the end of the stream to see if I can answer some of those questions. Now let me share my screen with you here and launch the software. So just like Forensic Email Collector, just to be clear, this is desktop software, so it's something that you're going to install on a workstation or a forensic laptop or a server or something like that. And it has three main modes of operation, I would say, and we'll go through those different options. The first one is what I call independent mode. So if you use it in independent mode, it's essentially kind of like a souped up email viewer with a bunch of capabilities built in. So to do that here, you would click this and the shell of it will pop up, and I'm going to point at a folder where I have some email data, and I'll drag an EML file into it to load it. Alternatively, you could just start directly from there if you associate it with the tool. If you double click and launch, it'll launch directly in that viewer, so you could use it just like that. Now this is one of those email messages that I had actually gone through in one of our email forensics workshops with a couple of minor modifications. So I'm not going to get into it too much in terms of what we can do analysis wise, but I'll show you some of the things that are possible with this tool now, so you can compare to what I did in the past with essentially a text editor and a few scripts and outside tools. Now the user interface of the viewer is pretty simple, just about any viewer probably that you've seen. We have a few tabs here. So the main tab is the MIME page. You might be familiar with how this looks from some text editors that support some MIME highlighting. So this is going to be where your either full MIME message lives if it's an EML file, or the MIME headers live if it's a MAPI file like an Outlook message. The render tab is when we render the message into an email message and display it to you, kind of like what, for example, an Outlook or Thunderbird would do. And then you have text and HTML version of the message body here for viewing in RAW and with some highlighting there. Now, I'll kind of walk you through it, and then on the right side we have a bunch of different analytical capabilities, and as we run into some things, I'll kind of pop those out and bring them to your attention. So let's kind of dive into the message to see it in action on something live. So if you pull up the appearance of this message, it looks like a simple message from one recipient to another between two people, one on Gmail, one on Yahoo, and then in the final message I am copied on there too, so I can throw my email address in the mix. So the first thing that I'm going to show you here is the entities panel. So entities is essentially when the tool goes in there and extracts certain data points to make them easier to list and then launch into different analytical capabilities. So for example, you can have a list of IP addresses encountered, domains, and contacts. And one thing I want to point out to you before we get in is that we see that this email message is among essentially three people, Trent, Mo, and Janice, and me added on. But right away I'm seeing an extra email address here. That's a Gmail address, and another Yahoo address here, which don't appear to have any place here. So that's something that we're going to pay attention to see where that's even coming from. Now, if you look at the MIME headers, so the bottom of this is obviously the body. The first thing that you'll notice is that there's quite a bit of highlighting going. This is similar to the text editors that do highlighting, but one difference we have is that there's quite a bit of information and capabilities built into here. One of them is if you hover over header fields, for a lot of them you're going to see descriptions. So most of the time these are going to come straight from the request for comments documents, the RFCs. So you'll find the definition of what the header fields and header field is supposed to store, and we'll bring it to you. Sometimes you'll see some extended information about them, like if you hover a DKIM signature, you'll see not just the basic definition, but what the tags would mean, so that you can have it in one place as you're looking at it, like, hey, these are the tags. And what is this tag again? You can just pull it up here and read the description of it. And then as the data goes, there's different data points we run into here, and based on what that data is, we do some work to enrich it. For example, for content length, we're going to automatically calculate the content length of the message and compare to what the header says. And in this case, it's red because there's a mismatch. The calculated length is 2023 and the reported is 2032. Just as a refresher, the content length is essentially the number of bytes in the payload here in the entire message. So that's kind of an indicator that tells you if the message may have changed since that value was calculated. Usually you'll run into this in Yahoo and AOL. And then there's the Xmailer header, which we'll get into in a little bit, but there's some information there. There's the next originating IP, so this is usually the sender's IP here. So here you'll notice that there's again highlighting, and if you click on it, you'll see that it pops up in a different view. So this is one of the enrichments that we're able to do, get some IP details for that IP address. Now you can use this as a general tool panel and put any IP address you want and go from there. But it's an easy way to just bounce into a specific IP that you want to look at. So in this case, we pull information about the city, the country, the location. There's an accuracy radius, which we highlight in a circle here. So this is the accuracy radius. It essentially means that this IP address owner could be anywhere in here. So this is not a very accurate IP address data set because it's accurate for 20 kilometers. So it could be anywhere in here. There's information about the population density, average income, the time zone there. But the things that I like more are there's the ISP information. There's going to be information about if this IP address is anonymous, it's a VPN, it's a hosting provider, is it a public proxy, Tor exit node, or anything like that. So quite a bit of information about what this IP address could be and how it ties into your investigation. Again, you could reach this by clicking on an IP address that's identified here, or you can go to the entities here and look at the IPs you have and hit one of these buttons to launch that in the viewer. Now for some of the IP addresses, if you hover over them, you'll see the reverse DNS for them. So we're going to automatically look up what it resolves to and show you that this is actually a Yahoo IP address, and it kind of matches what you see in the header there. Now moving on here, we have this content type MIME boundary delimiter, and if you hover over this, you're going to see that we identify this as a Java Mail or Yahoo Webmail type MIME boundary, and we decode the hidden timestamp in there and tell you that little bubble that it points to March 3rd, 2020, and it's coming from this epoch timestamp here. So if you look at the timing of the message, this was actually August 6, 2019. So the March 3rd, 2020 MIME boundaries out of place there. So we'll write that in the back of our mind. MIME version, nothing to see there. So I'm going to kind of skip over the not so important parts to cut to the chase quickly. If you hover over the message IDs here, so there's a message ID in references, there's a message ID in the actual message ID column. This one is an Outlook desktop type message ID, and again we decode this and tell you that this points to a March 3rd, 2020 timestamp. And this one is a Yahoo Webmail type message ID, again March 3rd, 2020. So just going back to what I was saying earlier, so this is how we analyze essentially the tool marks. So figure out, if you see a specific format of message ID, what kind of email client might have been at play or what kind of email server might have been at play. Same thing with these MIME boundary delimiters and code strings, as we'll see in a little bit. We see the recipients here. You'll see that some timestamps are easy to identify to a human, but they're still color coded just to catch your attention because they might be buried in here sometimes. So we follow along. These are agreeing with the time of the email, the apparent time, August 2019. Here we have the DKIM signature. So we have some information on what that entails. But you can click here and see if DKIM verifies. In this case, it does not verify. So here we're going out to the internet, fetching that public key, calculating the hash and all that, which happens pretty fast. But we're showing you if the DKIM fails or matches here. We highlight the domain because the signing domain is kind of important. So you want to be able to tie that with the message. And then if you click on it, you'll be able to do some intelligence on the domain itself, which we'll see momentarily. There's a timestamp here, hidden. Epoch timestamp that reflects when that DKIM signature is supposed to have been calculated. So we decode that, pointed out as March 3rd, 2020. Authentication results, some basic information about what that is. Again, hover over and you'll see the reverse DNS for the IP address here. SPF information, nothing crazy here. Here's another kind of hidden timestamp. So this actually blends in pretty nicely when it's not color coded, so you could miss it. So we just highlight that in green so that you pay attention to that. There's an extra timestamp there, as well as an additional one here. Some information here. There's one of the extra email addresses that were not supposed to be there. So when we looked at the senders and recipients, this email address was not one of those. So somehow it made its way in there to keep in mind. We have this X received header. Again, another hidden epoch timestamp here that we decode, and another human legible timestamp or human readable timestamp. Google SMTP source information, another received header, and finally delivered to, which tells you the final destination for that. And this is again an email address that's not part of the apparent recipients of the message. We saw that when we looked at the entities. So we're already kind of forming our opinion on this message because DKIM fails, content length fails, and there's a bunch of timestamps that seem to be out of order. The apparent time is August 2019. Timestamps are popping up that point to March 2020. So there's quite a bit going on here that doesn't look great. So one thing that we do in email analysis usually is to form kind of like a timeline of the email message. At least this is what I do. I would take a message like this and make a spreadsheet of all the timestamps that I could find and kind of sort them to see if the timing makes sense or if there's anything out of place. So this tool does this for you kind of automatically. So you click a button and you see this timestamps view. And all these timestamps that I highlighted earlier based on the message ID timestamps here, the hidden timestamps in the DKIM signatures, the receive headers and all that gets put into the spreadsheet view for you automatically. So in this case, it starts with the sent date of the message, which points to 2019 August. And then we have a bunch of received headers, which were the ones that the end user could easily read. And those are again 2019. And if you hover over these, you'll see which specific received header they're coming from. And when you look at them, you'll see that this received header, for example, has a -8 time offset for Pacific Standard Time. And this column shows the timestamp in its original offset. And then this column is UTC normalized. But you can sort these to see in whatever order you want to see them. So we have the received headers, and then we hit the timestamps that are the hidden timestamps essentially. So we have one from this message ID that we decoded, one from the MIME boundary, one from another message ID, and one from the T tag of the DKIM signature that you can see here. So we kind of put it together so that you have this good visibility into where these timestamps are coming from and do they make sense. In this case, everything starts out in August 2019 and then jumps over to March 2020, which doesn't make sense. Now, as far as intelligence capabilities go, another thing that the tool does, which makes your life, at least my life, a lot easier, is it offers you insights. So all this information that we analyzed manually and kind of put together, it'll attempt to do that and highlight the problems or just give you general information about the message. So first of all, it'll give it an insight score. So in this case, getting closer to red means there are some problems with the message. And the closer you are, the more issues you have. And here, if you look at the legend, there's essentially some informational data points that are just, FYI, but not necessarily a problem. There are some negative data points that cause some deductions in points. So essentially, it gets closer to red because of them. And then there are some positive data points that actually signal a positive message. For example, DKIM and ARC verification is a positive finding. So if you follow along, it tells you that the delivery of the message took 3 seconds based on the header information, which is just informational, not a big problem there. If it took 3 weeks, that would be something to perhaps be concerned about. It contains at least one failed DKIM or ARC signature, which is a negative point for this message. It says the MIME boundary found in this message is consistent with Java Mail or Yahoo Webmail. This is just informational, so that you kind of compose in your head, what email clients might have been involved, and does that jibe with your understanding of the case or the parties involved. And then it says the MIME boundary timestamp is after the date of the email, so that's kind of a problem. The date of the email is in August 2019. MIME boundary timestamp is in March 2020, kind of a problem. The message ID found in this message is consistent with Yahoo Webmail, which is informational, and that makes sense in this context, so we're good there. But it says the message ID timestamp is after the date of the email. Again, we have that problem. And then there's a general note about timestamps. So when we did the whole timestamp analysis, it says the latest timestamp we found is 30 weeks after the sent date of the email. So that's kind of a problem too. So why do we have some timestamps that are so far out? It highlights the fact that the content length doesn't match. I had mentioned that as we started out. It says the following header suggests the message was delivered to this Gmail mailbox, so that's informational, not necessarily a problem, but in this case it's kind of odd. Following header indicates it originated from this IP address most likely, so we already looked into that. Here, this header suggests this is the ex-mailer header, so we'll parse this out and try to match it to a known provider or email clients, in this case Yahoo Webmail. We point that out. Here we point out a spoofing related thing. It says that the from email address does not match the return path email address. So this is not always a bad thing, but sometimes it could be a sign of spoofing. And then a couple of interesting things here. So the one of them is the following code string is consistent with Yahoo Webmail. So here the tool is going and analyzing this code string here. And based on the format of it, it's determining that that is consistent with Yahoo Webmail. So if you are using Yahoo Webmail and if you reply to an older message, then that's how Yahoo presents the older message. But then there's one more here underneath, and it says the following code string is consistent with Outlook and plain text. So here we're going actually 2 levels deep to an older message in the thread, and we're parsing this part of it, and we're saying based on how this looks, this is consistent with what Outlook desktop client would do if ever replying to a plain text email message. Just so you know, it's not necessarily a problem. It's just introducing you to all the data points in the message for maximum visibility so you can make some good decisions about your case. Now going back to entity, so what else can we get out of this message? So we had some information about IP addresses. So like I showed you, you can trace all of these to see, you know, where they're coming from and get some information about them as far as location goes, or provider type, or VPN or Tor and whatnot. There are domains here, so you can do some domain analytics. So I'll show you one in our domain just to give you an idea. So if you hit this, the first thing you'll see is the raw whois information for the domain. For some domains, it's going to be redacted for privacy like ours. For some, you can actually see who registered the domain. But we will gain some basic information about the registration details. In this case, it says based on the current registration information, this domain is at least 4 years and 9 months old. We say at least because I'll show you why that is in a little bit. It's not necessarily exact like that. But this is important because if you're analyzing an email message and if you encounter a domain there, and if the domain was registered yesterday or last week, then that could tell you something. Whereas if it's you know, a domain that's been in use for several years, then that's a different story. So in this case, it's a domain that's been in use at least for 4 years and 9 months, maybe more. If you look at DNS, we pull up some DNS records to give you some visibility into this domain. For example, we pull up the MX records, the mail exchanger records, and here we can make a deduction that based on the MX records, the current email provider of this domain can be Office 365, based on how this is looking. This is something you might be familiar from Forensic Email Collector. That tool does that up front as you enter a target email, and it will automatically pick a profile for you. So here we use the same type of technology to give you a list of email service providers that could be at play here, and then we give you a list of historical email service providers that could have been used in the past. TXT records, I'll show you why we list these here. Name server records, A records, and a bunch of other things. So historical MX, historical mail exchanger records, are essentially a list of mail exchanger records in the past. So if we look now, we're going to only see the most current one. But if we use Security Trails API to fetch these historical records, so you can see what this domain was using as an email service provider in the past. So now it's on Microsoft. It used to be at Gandhi for a little bit, before that Amazon. And then we have some records here that don't have an identified organization, but it looks like the records go all the way back to 2008. So initially, whois was suggesting that the domain was in use for at least 4 years, but as it turns out, the domain has been registered prior to that. But the last registration is 4 years something old. Now, like I said, in any of these intelligence panels, you can plug in any information you want. So I'm going to put in, for example, a known big domain here to show you some details there. So for example, here's CNN, 28 years old, a lot of days there. If you look at DNS for CNN, you'll see that possible email providers based on MX records, Proofpoint. So it looks like they're using Proofpoint. So there's going to be some type of underlying email server there, but at least this is the middleman here. One of the reasons we list these TXT records is that sometimes they give you information about the technologies that are used at that target. So here, for example, you can see information about Stripe being in use, possibly MongoDB, GlobalSign, Facebook stuff, Cisco. So you can look at these TXT records to find out about additional email providers that they have, or additional just general data points about what that organization is doing. Name server records, A records, historical mail exchanger records. Again, this is going way back. We have another interesting thing here is subdomains. Again, we're tapping into Security Trails here to give you a list of the subdomains for the main domain. So if you're doing any type of reconnaissance, You could look at all these subdomains. Of course, CNN has many to figure out, the security stance of their organization, or what kind of subdomains they have, which could come in handy to have in one place. And what we have in terms of contacts as in email addresses is that if you click on one of these guys, you'll pull up our email intelligence capability. In this case, again, we're enriching the data. This is not something built into forensic email intelligence as built-in data. Obviously, it is coming from an external API called Sublime Security Email Rep. So we pull this information here, and it gives you quite a bit of data points about an email address, which could again come in handy. In this case, I pulled my email address. It says it has a high reputation, probably because it's been around for a while. A few references. It's not blacklisted. It gives a first seen date. This, it should have been seen before that, but that's the time that it knows about. The domain name, which is which is something that matches our who's information essentially. Is it a suspicious domain or a spam or anything like that? Here are a couple of interesting things. Number one, it says, is it spoofable? And it says false. So this is something to look out for. Just recently, I had a question about this. An organization contacted me and they said that they were seeing all these emails that appear to be coming from them, but they really are not. So they were wondering how this was even possible. And as it turns out, their email addresses or their domain was spoofable. So that means they hadn't really enforced DMARC or SPF. So anybody could send an email on their behalf and the email would not be automatically discarded. So you can look that up pretty quickly here. If the domain is spoofable, do they have strict SPF or do they have enforced DMARC? And does this email address have other social media profiles associated with it? I should have more, but I picked up these couple of them. So you can do some domain email address intelligence there, again built into the tool. And another intelligence point we have is URL intelligence. I don't have many examples of this here, but if you have a URL that's maybe it has some redirects, like a shortened URL, we will parse it out for you and show you the hops. Or if you have a complex URL that has some hidden information on there, then we put a little link here to unfurl with the author's permission, and it'll take you to a nice tool on the web where it'll parse out the URL for you and show you the different components of it, which is very neat. All right, so this is essentially what you get with a MIME message with this tool. So a few different intelligence capabilities and some built-in insights and timestamp analysis and DKIM analysis. And as far as tabs go here, I told you that you could look at text and HTML body. Something that I like to do is to compare them side by side a lot of times. And a quick way to do that is to actually dock these next to each other, and you can compare them side by side and see how they're looking at, if there's a discrepancy between the two different body format contents. So if one says one thing and the other says something else. We will probably have some more automation around this soon to make it into the insights panel automatically if you can find some type of discrepancy there, and then you can dock it back here automatically. Now this is what we have for MIME messages. Now those integrations that I showed you are configured from here. So like I said, we use currently 3 different external APIs for enrichment. One of them is the email intelligence from email rep.io, which is Sublime Security essentially. We do IP intelligence with MaxMind and domain intelligence with Security Trails. So these are all optional. You don't have to configure them if you're not interested in getting those data points directly in forensic email intelligence. But if you are, which I find it extremely helpful, then you can sign up to those services and bring your own API keys here and you're all set. So you don't have to deal with us for that service. You deal with them directly and you plug in your credentials into the tool. Now, let's look at an MSG message here to see some differences. So here's an MSG format message that I'm going to drag over here. Oops. So What we do with MSGs is largely similar, and I'm not going to go through the same type of things here, but you see the headers here. But for MSG, you're not going to have the full MIME content, so you're just going to see the message headers in the MIME tab, and actually the tab is named headers in this case, not MIME. You're going to see a render of the message, which we'll get back to in a minute, text body, HTML body, and we have an extra tab called Mappy here. So this is something that I always wanted to get and dive into the Mappy properties in individual messages. Has been kind of a hassle, and I used to use these third-party, either plugins to Outlook or MFC Mappy, which is a great tool, but not always super easy to integrate with your workflow. So we built this into FEI, where you can launch an Outlook message, whether it be individual or part of a PST or OST, and it'll list all the Mappy properties for you, color-coded based on what type of property they are. In this case, we're finding 174 of them. You can see just the name properties, you can see just the timestamp properties, and you can search them. So the timestamp properties are very useful to me because, like I said, I usually like to do a timeline of messages, and sometimes there will be some Mappy properties that represent timestamps, but you may not even know what they are. There could be any number of them. So it's good to be able to just filter all Mappy properties, find the ones that represent some timestamp, and pull them straight into your timeline, which we do here. So here we have 6 Mappy properties that are date-based, and you'll see all 6 of them are here in our timestamps view, automatically populated. Now you'll see an additional timestamp here, which we label as a thread start date, and that's coming from the conversation index value, and that's something you can find here if you search for conversation index. So here's the conversation index value that starts with 00101, and I had introduced this before, and we went over this, I think, in our Capture the Flag competition last year. But if you're not familiar, it's essentially a value that shows you some information about the whole email thread, any children messages, and the start of that conversation. So we pull in that same value here, parse it out, and give you the associated timestamp in context. I feel like this makes it a lot easier to investigate and search for specific Mappy properties and incorporate them into your investigation. Now, going back to this part, this is a good example. So you'll see that when you launch a message like this, a lot of times all the external images are going to be unavailable, kind of like what you see in Outlook, for example. If it is an embedded image that's part of the message, it'll show up. If it's an external message that requires to be fetched, we will put the brakes on there and stop that from happening. If you really want to see it, you could hit this Show Remote Images button, and we'll load those images for you. And if you wanted to print this, we have another handy button here to export the PDF. So let's save this here, for example. It will take a second to export, and then you can, let's see here, where did I put that? Yeah. So you'll see a nice print out of this that looks pretty clean, and you have the headers nicely represented. One thing that I've always wanted in these printouts is to have the actual time zone offset there. So we captured that and put that in the date and time, so it's unambiguous. You don't really wonder, there's a time there, but is it UTC or is it a local time? So we put it there. If there are attachments, we're going to list those on there as well. And this is a nice searchable vector PDF that you get out of this. All right, so now that we did a mapping message, we can talk about the other couple of modes of operation. So like I was telling you earlier, it's great to be able to do this kind of analysis at an individual message level and gain some insights automatically if you're investigating a specific message, and you can go from there and take parts of that and incorporate it into your report. But what happens is a lot of times you're actually not looking at just the one message, but you're given a collection of messages. It could be, for example, a data dump from Google Vault or Google Takeout, or it could be a number of ESI productions that you received, and you might be in a position to scan them and figure out which messages are likely to be fraudulent or problematic in some way. For example, I had a couple of cases like that where one of the parties was producing a large number of fraudulent messages, so not just one or two, but hundreds of them. And one of the tasks that I had was to essentially analyze those and try to put in a report, what the problem was with them. And ideally, you want to find the worst offenders first and cut to the chase. You don't want to analyze 10,000 messages and try to figure out which ones have what problems. If you can score them all and see the top offenders, then that's usually much better. Same thing, you might have a case where you've received a number of messages, for example, but you don't know if they're all legit or if there are some problems there. It's good to be able to just throw everything in a tool and have them score just the way we score the individual message with the insight score and figure out how things are looking across the board. To facilitate that, we also have a connected mode where the viewer works in tandem with a managing application. So I'll show you how that works. So let's create a new case here. I'll call this test project 1, for example. And let's call this T1. You can put some information here like details, reference numbers, client names, and things like that. And I will give this an evidence ID of 1, and I'll add a custodian, John Doe. Let's call this John Doe emails. And I'm going to add some evidence items. So I'm going to pull up my evidence source here. So I have a folder here for this demo where I have a few subfolders. I have a couple of EML files, which we looked at. I have a Mbox file from Google Takeout. I have a couple of MSGs, and I have a PST. So I'm actually going to just drop this whole thing there and let FEI ingest it. Now, once I drop this here, you see that a new row is created with the details of what I added. Now, you could add more evidence items if you wanted to, and the purpose of that is to separate things. So if you wanted to have different custodians, for example, you can add them separately, so you can kind of deal with them individually rather than as a whole. In this case, I'll just put everything in one place, say ingest. So you'll see that we got the top level items first, and now we started extracting. Now, one thing that's happening now is, although it's going relatively fast, we're not just inventorying these items, we're also doing all the analysis we did at the individual message level, and it's already done, and bringing that in and scoring them. So whatever DKIM and ARC signatures, timestamp analysis, all that is being done as we ingest, and we get the scores already assigned here. So let me auto-fit the columns here. So here we have a grid view, which I'm sure you guys are all familiar with this from other tools. This is a little bit different, but same idea. So the idea here is that you're able to kind of have everything in one view and then have a viewer on the side. So the goal is essentially to have this in one screen, perhaps if you have a multi-monitor setup, have this on one screen and have the viewer on the other screen. So you can click on a message and the viewer pops up, and then you can scroll through them and the viewer syncs and shows you whatever message that you're looking at. Now, one of the things you'll notice is, like I said, individually, as we ingested the items, we automatically did the DKIM and ARC signature verifications, timestamp analysis, and all the insights and scored them. So you can sort by score. And if you look at the bottom, the highest score we got, which is the worst offender, is the 75. This actually happens to be the message that we were looking at earlier, so we know that this message is bad in all sorts of ways. So this is one that that we had analyzed before. So here's another one that has a 55 score. So let's see what's wrong with this guy. So this is a message from next draft to this email address, and this is actually kind of an automated message, so there shouldn't be anything fraudulent about it. But let's see what problems the tool has spotted about this that caused its score to be elevated. So if you look at the insights, so you see I'm going straight there because it's easier for me to look at the insights first to cut to the chase, and then I can verify those myself going through the motions and looking at the headers and stuff. But this is kind of like a quick 1 second look at a message to see what's wrong with this. So some of the things that caused its score to be elevated are, number one, the message delivery took over an hour, which is a little bit unusual, not a huge problem, but it is flagged because it's more than a few seconds like it normally should be. The message contains at least one failed DKIM or ARC signature. So if you look at this, so you're familiar with this DKIM verification from our capture the flag competitions and stuff, but in this case this message has multiple DKIM signatures and an ARC chain. So we verified the whole chain and the chain looks good. The individual DKIM signature looks good, but this one here is not verified, and the reason is the public key is not there anymore. So although this message is recent from 2021, the public key they used in the DKIM signature is nowhere to be found, so DKIM failed, and that is a negative point for this message. And then the latest timestamp found is 1 hour and 4 minutes after its sent date, but in some cases this can be due to an export process changing internal message data, so that's likely what happened here. The timestamp is probably after the rest of the stuff, so I wouldn't be too concerned about that in this specific instance. Let's see what else it found. It found that the X-mailer header suggests that MailChimp was used, so it looks like this is, like I suspected, a mass mail, and they used MailChimp, which is one of those email service providers that send email blasts. So we identified that here from the X-mailer header, and we also confirmed that here by looking at this header field that suggests that the message was distributed through a mailing list, the list ID. So there's a list identifier here. And another concerning point slightly is that the email address on the sender does not match the return path. In this case, this is not necessarily a problem because there's a reason for that. The return path is to handle bounces. So what's happening here is MailChimp is setting up an automated email address so that when they send out the email blast, if there's a non-delivery report, an NDR coming back, they don't want those NDRs to flood the sender's, Dave's mailbox. They want to collect those NDRs and process them, and they want to figure out which email addresses are bouncing back, and then they're going to mark them in their database like, hey, this is a hard bounce, so this email address is not valid anymore. Let's drop this guy from the recipient's list, essentially. Or if it's a soft bounce, maybe it'll be a negative remark for that email address going forward or something like that. So here it's not spoofing, most likely. It's just a marker about a mismatch that's deliberate. All right, now, so this is what we found about this message. I want to show you a couple of things here. One of them is we have a little tree view here that you can use to focus on the individual data sets. So I told you that when we set this up, we had this John Doe as the custodian, and we added one evidence item. So if you wanted to, you could break this up and have multiple evidence items in the tree, and you can access those directly like this. In this case, what I want to do is I want to look at the individual data points like the Mbox import, for example, so I can show you some things from there. So for example, for Mbox, if I autofit the columns, you'll see that we have a couple of so this is a direct Google takeout export, and when we ingested this, you'll see that there are a couple of interesting things there. One of them is the Gmail thread ID, and the other one is the Gmail labels. So in this case, these are coming from the messages themselves. So this is not server metadata, but if you look at the message itself, you'll see that there's a XGM thread ID and XGmail labels fields that take out inserts into messages, which I personally don't like. I don't know why they do that, but they make it part of the message. And we pick it up and use that as server metadata for a couple of reasons. One of them is that these thread IDs are timestamps, or they contain timestamps. So if you want to incorporate that into your timeline analysis like this, so the Gmail thread ID becomes a thread start date here, and it shows up here. If there were a Gmail message ID, that would show up here too, but they don't insert that, so we don't have that information. And again, you have this MIME boundary delimiter, for example, extracted as a separate timestamp, which we have a separate tool to decode that, but this is all built in here. Now you'll see that there are a bunch of yellow timestamps here. These are what I call tentative dates. So they're not real dates, but just a data point to keep in mind. And in this case, for example, if you look at this ARC signature header, there's an S tag, which is the selector for DNS. So we use that selector to access that specific public key. And the selector has what appears to be a timestamp that points to 2021 January 12th. Now this is not really a timestamp that's associated with this email directly, but it's something to keep in mind, because if our email's timing information on its face was before 2016, for example, then I'll be a little bit concerned about that, because we have all these selectors that are pointing to 2016 and later. Why is our email from 2014? So that's why we include them in your timeline analysis, but they're not direct timestamps. Whereas there are some timestamps associated with those ARC headers, like this guy, which is the T tag, which is a real timestamp. So that is a timestamp that's associated with when this ARC seal was sealed, essentially. So we have a real timestamp there, and it makes its way into the timestamp analysis there. Let's see here. Anything else that I want to show you? Well, while we're here, something else that I should briefly mention, which I like personally, you might like it too. We also have a dark mode as far as UI goes, so you could flip everything over to dark mode if you're working at night and you want to avoid the eye strain. You could do that from up here or down below from the viewer tool. They are both connected, so they'll do the same thing. And you'll see that an additional UI element popped up here for a flag. So this is connected to this is flagged data point here. Let's see where that is flagged. So you could, as you're analyzing the message, if you want to flag something so that you can go back to it and filter for it, it'll just pop up there. Or if you wanted to grab a few of these guys and flag them, you can do that, so that you can refer to them later. So like a basic tagging mechanism, so that we can leverage our tags for review. Again, you can use this label field to run some really quick searches. Like you want to search for any emails that have the Lorenzo label, for example. Boom, you could just filter for that. And actually you could do some pretty complex filtering with ands and ors and multiple different types of operations. So I'm not gonna really go through all the details of the grid right now, but there's quite a bit of flexibility on being able to move the fields around, show and hide fields, sort by certain fields, filter by certain fields, and all that. And down below we have our PST import that also has these items we imported from the PST. That looks like this. Same thing as a regular MAPI item, essentially, with the MAPI fields and all that. Now this is how you would get some external data into this. So let's say that you received a bunch of Google takeouts or a bunch of ESI productions, and you have native files and you want to throw them in here and score them. That's how you would do it, and you can just ingest them here and see what you get. Now, some of you might be wondering, so we have this other tool, Forensic Email Collector, that collects emails, and how do you transition from there to here? Well, you can do it a couple of different ways. One of them is, I'll create another project for this. So let's call this test project 2. I'll skip over the case details here. And let's call this evidence edit 2. Again, John Doe. All right, so remember we dropped some paths there in the past. So if I go back to my data here, so I have a couple of FEC projects that I acquired and completed earlier. Now you could do this two ways. One of them is you can drill into your FEC project, find the type of output that you want, like MIME or PST or whatever, and drop that in here and ingest it like any other email data point. And it will ingest MSGs or MIME or PST, so any of FEC's outputs would be fine. But what I would recommend that you do is that instead of that, direct your FEC project file there directly. I'll drop actually two FEC project files. One of them is for a Gmail API acquisition, and the other one is for an IMAP acquisition. So the benefit of dropping the FEC project is this: we have this extra capability in FEC that we capture server metadata as part of the acquisition. So not all that server metadata makes its way into the individual email messages, because email messages are one thing, server metadata is something that's outside of the message. The timestamps carry over because we kind of enrich them. But things like, you know, thread IDs and conversation index values and all that, IMAP UIDs are not going to be within the messages. So if you throw your FEC projects in here, then FEI will take the data directly from the project, pick the best type of output that's suitable for email analysis, ingest it, and enrich it with the server metadata that we got. So let's put this here, ingest. So 2 top-level items that are the FEC projects. We're extracting the Yahoo item now, the Yahoo acquisition. Oh, I guess the takeout was, sorry, the Gmail API was already done before I could get to it. All right, so if we look at the Gmail API acquisition, it's out of its columns again, you'll see that it's largely the same. We scored everything again, so you have all that information automatically captured as we ingest. There's no separate process for it. But as far as special things go, you'll see that we ingested service IDs and Gmail thread IDs here, in addition to what you would get, and Gmail labels. So these are things that were not in the messages, but things that we ingested from the outside. Because if you look at the message, because this is FEC's acquisition, it doesn't have those additional header fields inserted by Google Takeout. So you have the original message as it is, and then all that server metadata is outside of it. But because we imported that information, again, it makes it into your timeline view. So you have your Gmail thread ID as a thread start timestamp, and you have your Gmail message ID this time as a regular message timestamp, and you have your sent date as kind of like the main line to pay attention to, and then a couple of tentative dates here again. Let's see, and if you look at the IMAP acquisition, we'll see something similar, I bet. We will see some server metadata again. So in this case, we have service IDs, which are critical, especially for remediation projects. This is something that comes up a lot. A lot of you are asking about Obliterator and how you remediate mailboxes. And the starting point has to be to capture the service ID for your target mailbox or individual messages, so that you can do your analytics and review and all that, and then arrive at a subset of the messages retaining their service IDs, which you can pass on to a remediation tool. If you lose the service ID, then you're in trouble, because matching things up is a lot more difficult. So we transfer those over. You have the service IDs, you have the IMAP UIDs, which, if you recall from our past workshops or blogs, we do IMAP UID analysis. So, you know, just to refresh your memory, these UIDs are the IMAP unique identifiers, and they're integers, and they are incremented as new messages arrive in a mail folder. So if there's a gap there, that could indicate a deletion. If there's something out of place, when sorted chronologically, it could indicate alteration and maybe a syncing back of a message back to the mailbox. So we look at those carefully next to timestamps. So you could move your IMAP UID column here next to your internal dates we capture and set as the timestamp, and you can see them side by side and see if there's anything strange about them. You're going to see that we also capture the IMAP flags. So if you're interested in flags, like if a message has been seen, or is it recent, or is it junk or draft or anything like that, you'll be able to see all those details here. So there's quite a bit of server metadata import going on here that stands to, you know, enrich what you see in the tool. Now I'll clear this filter. Let's see, I want to go take a look at this mbox again. Let me see if there are any items with attachments. I wanted to show you something about attachments real quick. So let's do a quick has attachments search. Let's see if I clear this filter. All right, so I think this one is an attachment. So here's a message where content length agrees, and if you look at this, it has an attachment. And I've seen this before in forensic forums and message boards before, that there's a general consensus or some opinion, I guess, that email attachments lose their timestamps when a file is attached to an email. That's not always true. In some cases, you will have file system timestamps for an email attachment. In this case, this is a zip file, for example. So the zip itself doesn't have embedded timestamps, but it has file system timestamps that carried over to the parent email as it was attached. So you'll be able to see those in FEI's attachment view. You can save this attachment out or open it if you wanted to, but this will also make its way into your timestamp analysis here. So you'll see the creation date of the attachment, you'll see the last modification date of the attachment, along with anything else. All right, so this is how the connected view, I would say, works. So you ingest your messages and you drive from this grid view, and you double clicking opens the viewer, and you can have them side by side. And as you go through, the new message is going to get loaded essentially. I would recommend, like I said, separating these so they're not overlapping, maybe on two different monitors or on a very large wide monitor, so that you can clearly see things without having to worry about the overlap. In this case, I have a kind of small screen here because of the presentation, so I can't really show you how that would work. Now, a third mode of operation is essentially similar to that connected mode, but you could also use the FEI viewer as a viewer to an existing forensic suite. Now, for example, an example of this would be X-Ways. X-Ways allows you to launch a file that you're looking at with an external viewer that's perhaps an app that's associated with that file type by using a keyboard shortcut. So if you need a forensic suite in your workflow, so you want to maybe ingest a whole forensic image and you want to just make a searchable index and get your emails that way, then you can narrow things down to your emails. And in your email review workflow, if you wanted to look at certain emails in more depth, then you can launch them off to FEI on the side and have a similar workflow to what I just did with the connected view. But instead of FEI's built-in grid, you could have another tool there. I haven't tested in all the tools to see which ones would support this nicely, but I bet you most of them would. And if they don't, most of them could, because it's as easy as just launching the file off to an associated program. And you could have essentially something that complements your existing forensic suite rather than a wholly separate tool. And that's what I would recommend, because we don't see this as a replacement to the major forensic suites, because they do 100 things that we don't. They're just more general purpose. They do nice connections between different type of data points. They parse all kinds of data. This is not what we're after here. This is like Forensic Email Collector. This is a very specialized, narrowly focused tool that goes into a lot of depth. So I wouldn't tell anybody to ditch their forensic suite and get this instead. What I would recommend is, if you do any type of email forensics work, you could add this to your toolkit essentially, so that when you look at an email, you have a more comprehensive tool that could do a lot more detailed analysis on the intricacies of emails, so to speak. Now, as far as use cases go, like I was going to mention, obviously I would say probably the most prominent use case is email authentication. So if you have a case where you're not just after e-discovery, as in searching and producing emails, but perhaps you started off that way and some emails authenticity got called into question and you need to really analyze them, then this is where this tool comes in. You do detailed analysis on individual emails or a collection of emails. Same thing with spoofing. If there is any question about the origin of a message, or if something is not authentic, then you can fire this tool up to see if everything is in agreement, if there's any problematic data points in the insights, if the IP addresses are making sense, if the reverse DNS is making sense, get some intelligence on those domain names and IP addresses and email addresses and URLs and all that, and put that to use essentially. Same thing with malware. If you're investigating malware you could have some emails where a malware was dropped, and you might want to get to the bottom of how this happened, where it came from. Use a tool like this to get some insight into the process. An unexpected use case that I've found is this. Needless to say, I've been using this tool for a while now, although we're just introducing it. I've found that this also makes a perfect companion for presentation, because a lot of times when I do email work, I have to present my findings to somebody like a legal team, for example. And if I just go over the details in a Zoom meeting or over the phone, then a lot of things that I talk about are very abstract to somebody that's not involved in email forensics, like a legal team or an individual attorney. Even if they are kind of technically minded, they may not understand all the details about DKIM and ARC and why something is out of place. But if you use a tool like this and share your screen, because it's so visual and everything is right in front of you, it makes it a lot easier for people, or maybe non-technical people, to wrap their heads around why there's a problem with a message, or if you're not seeing what you expect to be seeing, what else is needed to complete your analysis. And I've done it a few times with clients now in doing professional services, presenting findings, and they've been blown away. They were like, wow, this is pretty awesome to be able to see all the detail that one could extract from an email message. So that might be a use case that perhaps you haven't thought about, but I found to be extremely helpful. Now, I see that we are at about the 1 hour mark, so I'm going to turn my attention now to the chat on YouTube. I see there are quite a few messages, so I'm going to read and see which ones I can answer. Let's see, one question about insights query to a custom Cortex server. That's not something that's built in right now, but happy to talk about that to see what we can do there. Oh, I think that was a part that I neglected to share my screen for about 8 minutes. So I'm gonna have to go over that very quickly. So let's see here. We haven't had share screen for the last 30 minutes, Jessica says. Oh, that's my bad. Sorry about that. So let me share. I think where I lost you guys was how to deal with multiple emails. So let me do a quick retake on that. You've heard me talk about this, but I haven't shared my screen clearly. So let me do a quick retake. If anybody's interested to stay a few minutes longer, you're welcome to do that. Before I forget, let me share my screen this time so you can see. All right. So we were talking about dealing with multiple emails. So let me do that one more time on a couple of different scenarios so you can see how that works. So one of them was this, what I call connected mode. Essentially, connected mode is you create an FEI project here. I'm going to call this project 3 in this case. I've done 2 already. And I'm going to give it an ID and an output path. So let's call this T3. All right. So create this project. I will give this an evidence ID and call this John Doe for the person. Let's say John Doe mailbox, and I will add some evidence items. So I was telling you that I have this list of emails, this list of data points here for the presentation. I have a couple of EML files, a Google Takeout, a couple of MSGs, and a PSD. So I'm gonna just drop this all in here and add this. So you'll see that you have this one line here for John Doe, and you could add additional evidence items for different custodians if you wanted to see them separated so you could deal with them individually. Now I'm going to ingest this, and we got the top level 6 items here from the individual EMLs and the PSD and the MBOX and a couple of MSGs. Now we're doing the takeout file. Now we're going to do the PSD file, and done. So when you launch this, so it's just becoming clear to me now that this is the first time you guys are seeing this, so I'll go over this kind of slowly. So I'll auto-fit. What I was saying earlier was that as we ingest these data points, although it goes kind of quickly, as we ingest, we do the scoring and insights on the fly. So all the DKIM and ARC lookups and everything happens as we do the ingestion, and you see that they already have insight scores here. So you could sort by insight scores, for example, and look at this worst offender here. And this was the item that we looked at earlier, which had all sorts of problems with it. So I'm not gonna go on that much longer. I showed another message here which had some problems, and when we looked at this message's insights, we found that this was a message that was sent through MailChimp. So FEI identified that it took an hour and 4 minutes to send, so that was kind of a red flag. It failed one of the DKIM signatures, so it didn't fail ARC, but one of the DKIM signatures failed, and that was because the public key was unavailable. So when they sent the message, they discontinued that public key for some reason in their DNS, I guess. So DKIM failed. There was some information about the latest timestamp being a little bit later than the message, and some information about MailChimp being used and the message being part of a mailing list. So some FYI type data points that you could use to essentially get to the bottom of what's happening here. There was a discrepancy between the from email address and the return path, and the reason for that was that the email service provider here, ESP MailChimp, is using a different return path so that the bounces and NDRs don't go back to the sender's Dave's mailbox, but they go back to MailChimp for processing, so they can do some identification there. So I wanted to show you a couple of things there very quickly. One of them was looking at the mbox file. We were able to see some additional server metadata. Sorry, not server metadata, in this case some Gmail thread IDs and labels there. These are not server metadata. These are inherent inside the message. So if you pull it up, you'll see that Takeout inserts these header fields into messages. I was saying that I don't really like this very much because it kind of changes the message, but they do this, and we parse these out because the Gmail thread IDs have a timestamp in them, and the labels are useful for categorization, obviously. So you'll see the thread IDs make their way into your timeline view as a thread start date. It's right below the sent date here. If there were a Gmail message ID, that would also be here. And then you see a few tentative dates here. As I said earlier, these are coming from the S tags of the ARC and DKIM signatures. They are some type of timing data point, so we take them into consideration, but they're not really directly tied to the email message. So if the email message had a time that was before all these, like in 2015 in this case, then I would be concerned. But for anything that's beyond this point, it's not really a red flag. We just put it there as an FYI. If you look at the let's see, the PST here. So we did the mbox one. Yeah, so I wanted to show you also, yeah, the labels you can filter here. So I think that's one thing that we did. So you could easily search your labels for a specific label, for example, and narrow things down and cut to the chase there. There are a few filtering and searching capabilities built into the grid. I'm not going to go over those, but you can rearrange them, sort them, filter by the grid, and do a few interesting things there. Now, one thing that I did want to do was show you how you would import. Let's see, I think one other thing that we did here was to look at the attachments. Let me see if this data set has any attachments. No, this is not the one that I wanted to look at. All right, so the second import that we did was to import an FEC project that I was telling you that the preferred method there was to import the project files themselves. So let's call this test 4, and let's go to T4 here, and let's give this an evidence ID, and again a custodian name. All right, so I was saying that I have a couple of FEC projects here, so you could go and import the contents of these FEC projects, like the extracted data, like the MIME items or the PSTs or MSGs if you wanted to. But I recommend getting the projects themselves, because when you do that, then we enrich what you get with server metadata. So I'm going to ingest these real quick, and you'll see that we're doing the Gmail API collection first, and then the IMAP collection from Yahoo. And when we look again, like earlier, we have this scoring already done for us. For the Gmail API collection, you'll see that we have service IDs this time, and Gmail thread IDs, and Gmail labels, and the service IDs were useful for looking at that information here in the timestamp. So in this case, the Gmail thread ID becomes the thread start date in your timeline view. The Gmail message ID becomes an individual message ID that you can reference here. And then, let's see here. Well, something else that I showed here was the dark mode. You could flip over to dark mode here, and if you're working at night, you can use this to kind of minimize eye strain if you're into that, or use it on light mode in any case. But the idea here is, in this connected mode, you have essentially this viewer and the main application connected to each other. So whatever you choose on one side is reflected on the other side. So you would normally want to put these on probably separate monitors. So you have this grid view on one side and the viewer on the other side, and you can manage it that way. Or you can use a wide monitor and keep them side by side if you wanted to. And something else you see here is that you have this document flag option that you can use to flag documents. Now, if I can find a message that has attachments, one thing that I wanted to show you there was how we handle attachment timestamps. So in this case, this one, for example, has an attachment. I was saying earlier that sometimes when you attach a file to an email, even if the file doesn't have internal timestamps, it could have file system timestamps that make their way into the email message, and we extract those and make them part of your timeline view here. So you could have attachments creation time and last modification time. You can see it in the context of your main timeline analysis there. Let's see, and yeah, for the third option of using it in tandem with an existing forensic suite, there was nothing to show there, so I did not share my screen, but it was mainly about these couple of import options and the grid view here. One thing that I wanted to show you was this IMAP collection here. If you look at the IMAP acquisition, we do have a couple of extra server metadata data points here. One of them was the service ID and IMAP UID and IMAP flags, and I was telling you that we could bring the IMAP UIDs next to your creation dates, for example, and do that kind of IMAP UID gap analysis to see if there's anything either out of place or any gaps in your UIDs that could point to somebody having deleted messages or edited a message and synced it back to the server after the fact, and you can see it all in here. Well, something else that I haven't mentioned before, but I should now, is because of the way we approach email and categorize all these different data points specific to email, like MIME boundary delimiters and message IDs. You could search or filter by those, which could come in handy if you're wondering, for example, if in your data set there are multiple messages with the same message ID or with the same MIME boundary delimiter, or if you're looking for a certain set of messages that share the same type of MIME boundary delimiter. You could group by those using the grid and focus on those, or tag those and look into them a little further if you wanted to. All right, I think I kind of sped up this last part, but I believe I was able to catch up to what I didn't get to show you guys on my screen, so it should have been a few minutes. And I think that's all the questions I had. So let me see after Jessica's questions. All right, I think that's it. If you have any other questions, feel free to drop them in the chat. If not, I will conclude this for now. As far as what next steps we have, you may remember that we had a waitlist going for this. Some of you subscribed to get some early access and some perks. So we're going to go through that waitlist now to reach out to you guys and make it available with whatever perks there are. And then we will revise our website in the next few days, and probably in about a week we should have FEI open to the public for anyone who wants to purchase and use it. And once that's done, the next thing coming from us will probably be our next email forensics capture the flag competition for this year. We did one last year. Now we will do this in light of the new research and some new things that we discovered to cover new ground. So you should expect that coming from us later this year, and we'll go from there. If you have any questions or if you wanted to reach out, feel free to either reach out to me on LinkedIn or you can send me an email through Metaspike, and I'll be happy to answer your questions. Thanks again for your time, and see you next time.